Alright guys, so now that we've graphed, we're into about transformations. But before we get into transformations, I kind of want to review what we've done before. So graphing calculus exploration is what we're going to do today, but we're going to start with this. Y equals x squared minus 4x minus 12. I want you to name the vertex, the axis of symmetry, and get the solutions on your graph. So we're going to go to Desmos, and we are going to graph that. So to answer our first question of name the vertex, we need to find the lowest or highest point on our graph, and this one is the lowest point. So we're going to click down here. Our vertex is 2, negative 16. All right. So then it says the axis of symmetry. Well, the axis of symmetry is very closely related to the vertex. So at 2, negative 16, we're going to look at the x value, and our axis of symmetry is at x equals 2, because if I draw a vertical line right here, and I fold the parabola in half, then it's going to be the same on both sides. So we say x equals 2, that vertical line right here, and I'll even graph it, that right there is our axis of symmetry. And then we have the solutions. Remember, the solutions are where it crosses the x-axis at. So if we look at this, negative 2 and 6 are where it crosses the x-axis at. So those are the solutions to the problem. So x equals negative 2 and x equals 6. So that's just a nice review of everything that we've kind of done so far. So then it says, on a graphing calculator, make a quick sketch of the graph noting the position of the vertex at least 2 other points. This is called the parent function. So we're going to go to y equals x squared. We call this the parent function because there are no transformations yet. So our vertex is at 0, 0. Which means our axis of symmetry is at x equals 0. Okay? And now notice some other points. When I go to 1, it's at 1. Because if I were going to plug in 1 to a table here to create a table of values, I would get 1 as the output. Now if I go to 2, I plug in 2. What is 2 squared? Well, that's 4. So 2, 4 should be a coordinate. And you look at it, it is. 2, 4 is a coordinate on this graph. So when you're graphing this, I would start at 0, 0. I would go to 1, 1. I would go to 2, 4. And then I would go to 3, 9. The nice thing about this, though, is that it is a parabola. So parabola mirrors on the other side. So if I go to 1, 1, that means I can go to negative 1, 1. And I can go to negative 2, 4, and negative 3, 9. So now we're going to transform this parent function input into y equals x squared plus 3 and y equals x squared minus 4. So I'm going to go ahead and graph that first one just so we have it as an example. So 0, 0 is my vertex. 1, 1, 2, 4. And we're going to graph our parabola. Okay? So now we're going to transform this. So it says y equals x squared plus 3 and y equals x squared minus 4. Let's see what it does to the parent graph. So y equals x squared plus 3, if we look at this, 0, 0 went up to 0, 3. And then 1, 1 went up to 1, 4. So let's kind of compare those. 0, 0 went up to 0, 3. And 1, 1 went up to 1, 4. And I bet 2 goes up to 7. So I don't know if you guys are noticing this, but I am moving the graph up when I say plus 3. So this would be upward when I say plus 3. So what do you think minus 4 is going to do? Hopefully you're sitting there saying minus 4 should probably move the graph down 4. So let's go graph it on Desmos and see y equals x squared minus 4. And let's compare it to the parent graph. Well, the parent graph's still here at 0, 0, but this one went down to 0, negative 4. So don't you think we moved it down 4? Well, let's try 1, 1. Let's see where it went. 1, 1 went down to 1, negative 3. So they all went down 4. So if I'm adding or subtracting, and it's on the outside, there are no parentheses, that's going to move it up or down. All right. Now let's try and put it in parentheses and see what it does. So we're going to compare this to the parent function. So x plus 3 squared in parentheses. I went from 0, 0 to negative 3, 0. And I went from 1, 1 to negative 2, 1. So to me, it kind of looks like we're moving it left 3. But that says a plus 3, so why is it left? Well, remember, I know Miss Sanders uses the Spider-Man analogy, but I always remember if they're in the clubhouse inside parentheses or under a square root, they are lying to you, which means they're going left or right, but they're going the opposite of what you think. So if it's plus 3, that means I'm actually going to the left 3. So move all my points left, and I'm going to graph it. So what do you think about minus 4? It's inside parentheses. Well, hopefully you're saying I'm going to go right 4. And so if I graph it, and I want you guys to do that, you'll see that every point will go right 4. Okay? So now it says, can you predict what this is going to do? Well, remember, we know if it's inside the parentheses, that's left or right, but they're lying to us, so we're going to say this is going to go right 3. And we know the outside is going to go up or down, and they're telling us true, so that's going to go up 2. That's my guess. On this one, plus 3, we're going to go left 3, because it's inside parentheses. And then the minus 1 on the outside means we're going to go down 1. And you can graph those and see. Well, now let's check, do these rules work for other types of functions? So let's look at the square root of x. Okay. So we have the square root of x. So you would graph that. Now, if you notice, I wanted you to do plus 3 on the outside. So what are you guys thinking is going to happen compared to the rules that we've had before? Well, to me, if it's on the outside, that's up or down, and they're telling us the truth. So I'm going to think it's going to go up 3. And would you look at that? Where does it go? It goes up 3. All right? So now, if we put it inside the parentheses or inside the square root, right, that's going to be left or right, but they're lying to you. So this says x plus 4. So that means we're probably going to go left 4. And if you notice, where do we go? We go left 4. So these transformations are consistent across the board. Now they look a little bit different depending on the function. So this next one is an exponential function. So I want you to type that one in. Y equals 3 to the x power. Well, that's an exponential growth. We've talked about that before. Hopefully we've remembered these. Plus 4 on the outside. Well, if I do that, would you look at that? It's going to go up 4. So from 0, 1 to 0, 5. So now if I put it in the exponent, aka in parentheses, because you have to do that here on Desmos, it should move it left or right. If it's plus 3, that means we should go left 3. So from 0, 1 to negative 3, 1. So it's proving to be true that it works depending on which way you move it. So now if we do absolute value, well, that's what an absolute value function looks like. It looks like a V. So now I'm going to do plus 2 on the outside. So hopefully, again, you're kind of getting the theme here. We should be moving it up 2. And what do you know? we move it up 2. So then if I put it inside the absolute value, they are lying to us. And so we're going to go, hopefully, the opposite direction of what you think. So this is -3. So normally you want to say, oh yeah, I'm going to go left 3. But actually we're going to the right 3. Okay? So now, one last extension. What does a number do in front of a quadratic? So I have y equals x squared. Now let's make it 5x squared. Get rid of this one. If you notice, x squared, the black one, is my original one. Now if I put a number in front, I'm multiplying. Well, that's going to what we do call a stretch. We're stretching it away from the x-axis. So if you notice, it's a black line. So if I want to stretch it away from this x-axis, this flat line, I need to get closer to the y-axis. So what are we doing? We're squeezing it to make it closer to the y-axis. We're stretching it away from the x-axis. So now, instead of doing a whole number, we do a fraction that's less than 1. This is called a compression. So if I get rid of the red one and compare it to the black one, we're compressing it towards the x-axis. So we're trying to press it down. We're making it flatter. All right? And so those are the transformations. I'd really want you guys to graph this on your own paper and write your own assessments. But transformations are fairly consistent across, any kind of graph you see for the most part. So if you guys have any questions over this, please let me know. I'd be more than happy to help. We can set up a tutoring session and figure this out. Otherwise, that's really it for this video, and I will see you guys later.